I came across this very interesting limit. So the limit is as x goes to 0 of 1 plus x to the 1 over x divided by e, all raised to the 1 over sine of x, okay? At first glance, if you just plug in limit as x approaches 0, right over here, this expression as x goes to 0 is actually equal to e, okay? So the limit as x goes to 0 of 1 plus x to the 1 over x, this is equal to e, which is actually also equal to the limit as x approaches infinity, 1 plus 1 over x to the x. Okay, so this is how e is defined to be, and there are many examples online on why this limit is equal to e, because due to continuous compound interests, but I won't get into that here. The main focus on this is that suppose we know that this is equal to e, okay? If you have this, then what you have is e divided by e to the 1 over sine of 0, 0. You have something in the form 1 over infinity, okay? Or maybe even not 1 over infinity, 1 to the infinity, or you have 1 to the negative infinity, depending on whether x is approaching 0 from the right or from the left. Okay, so in any case, we have like a 1 to the infinity situation. Okay, so this looks like we need to use L'Hopital's rule to do this problem, okay? And indeed, let's just use L'Hopital's rule to do this problem. Okay, so this is going to equal to the limit as x approaches 0. For this base, this base is 1 plus x to the 1 over x over e, whatever is inside the square brackets. I'm going to take that and raise it using base e. So e to the ln of 1 plus x to the 1 over x divided by e. This right over here is equal to that, because e to the ln of a is equal to a, of course, provided that a is positive. Okay, and the reason why is because ln of a is the exponent e needs to be raised to give you a. Now e is raised to this exponent, therefore it should give you a. Or you can say ln of a, if I say this is equal to y, then e to the y is equal to a, which equals to e to the ln of a. Okay? They are inverses of each other, the logarithm and the exponential. Okay, so now this is being raised to the 1 over sine of x. Okay, so now in order for me to continue, actually, you see right here that I could actually use log laws to break up this fraction over here. So what we have is we have this is equal to the limit as x approaches 0 of e to the ln of 1 plus x to the 1 over x minus ln of e, and then all over sine of x. Okay, so far I didn't use any L'Hopital's rule. I'm just using algebraically rewriting this expression into something else, because in general, when you're solving limits with something in the form 0 to the 0, 1 to infinity, infinity to the 0, you have to raise it to ln. So if you have, let's say, f of x to the g of x, and then when you take the limit as x approaches a or something of f of x to the g of x, you get one of these three forms. Then you have to take the limit as x approaches a of e to the ln of f of x g of x, and then from there apply L'Hopital's rule using for the exponent. Okay. So now, right over here, we see that this exponent 1 over x can come down to the front. And of course, ln of e is just 1. E to the 1 gives you e. Ln of e is equal to 1. So this is equal to the limit as x approaches 0 of e to the 1 over x times ln 1 plus x minus 1 all over sine x, which equals to limit x approaches 0. Right over here, I can write 1 as x over x. So I have 1 over x ln 1 plus x minus 1 over x times x. And this is all over sine of x. Of course, e is raised to all of that. Okay, so now let's just clean this up a little bit. The 1 over x's right over here, you can factor them out. If you factor them out, you get the limit as x approaches 0 of e to the 1 over x multiplied by ln 1 plus x minus x. This is all over sine of x. Now, I don't like this embedded fraction because we have like a fraction within a fraction. But we see here that this 1 over x, it's being multiplied by this fraction. Okay, so then this x goes downstairs. Okay. Essentially what we have is the limit as x approaches 0 of e to the, we have 1 over x multiplied by ln 1 plus x minus x all over sine of x. Okay. So then right here, the x's and sine of x multiply. 1 times ln 1 plus x minus x is just ln 1 plus x minus x. So this is equal to the limit as x approaches 0 of e to the ln 1 plus x minus x all over x sine of x. Right, this is just all algebra. Okay, nothing I did here involved derivatives. This is just all algebra. Okay, so if you don't remember your log laws, your exponent laws, fraction rules, please how to factor all those laws, please review them. Okay, and besides, at the university level, one should be able to know these things that were taught in high school. So make sure to go back and review them. If you haven't done them in a very long time, for months, do review those concepts. Tons of videos online on YouTube that will teach you for free. Okay, so now we see here that if I put x, if I send x to 0, now because these are all continuous functions, okay, I just plug in my value for x. I will have, what do I have in this exponent? I'll have ln of 1, which is 0, minus 0 is still 0, divided by 0 times 0. Sine of 0, 0 times 0 is 0. I have a 0 over 0 situation. Okay, we can use L'Hopital's rule. This is equal to LH, L apostrophe H. Okay, stands for L'Hopital's rule. So it'll be L'Hopital's rule. So if we have an indeterminate form of 0 over 0, infinity over infinity, what you can do is you can take the limit as x approaches 0, e. Now we're applying L'Hopital's rule to this fraction in the exponent. What you do is you take the, if you have an indeterminate form, okay, then what you can do is you can take the derivative of the numerator, and then you take the derivative of the denominator. This is not quotient rule. Okay, we are not doing quotient rule here. We're doing L'Hopital's rule. L'Hopital's rule is not quotient rule. Okay, L'Hopital's rule. We are taking the derivative of the numerator independently from the derivative of the denominator. Okay, you just take them separately. Okay, so the derivative of the numerator is going to be 1 divided by 1 plus x. That is the derivative of ln 1 plus x. And then the derivative of negative x is negative 1. Or we're subtracting the derivative of x, which is subtracting 1. Okay, and then all over x sine of x. That is the product rule. So now we see here that we take the derivative of x sine of x, which is going to be, we're going to use the product rule. Derivative of x is 1, so it's just 1 times sine of x, plus x times the derivative of sine x. So the derivative of sine x is cosine x. This is product rule. If you don't remember this, go back and review it. Unfortunately, we see here that if I do plug in x equal to 0 again in this numerator, I get 1 minus 1, which is 0, and then right here sine is 0, 0, plus 0 times cosine 0, 0 times 1 is 1, 1, okay, cosine 0 is 1, 1 times 0 is 0, 0 plus 0 is still 0. This is again indeterminate, but that is okay, because as long as we get indeterminate form, we can keep on using L'Hopital's rule. Okay, so that is equal to the limit as x approaches 0 of e to the. Okay, so now we differentiate the numerator. The new numerator is 1 over 1 plus x minus 1. Now the derivative of that is going to be negative 1 over 1 plus x squared. Okay, and I will not show how that is done because that is just an application of the power rule, and you go back and review that. Okay, so now in the denominator we have the derivative of sine of x, which is cosine of x, and then plus, okay, we have x cosine of x, which means we need to use the product rule again. The derivative of x is 1 times cosine x. That's what we have. Okay, plus x times the derivative of cosine x. What's the derivative of cosine x? Negative sine x. So times negative sine of x. Okay, now let's see. When I plug in x equals 0 here, I get e to the negative, okay, so 0 here, plug in 0 here, 1 plus 0 is 1, 1 squared is 1, 1 over 1 is 1, so I have negative 1 all over. Putting 0 in this denominator, I get cosine of 0 is 1, cosine of 0 is 1, this is 0, so whatever this is 0, so I get 2. 1 plus 1 is 2, okay? So e to the negative 1/2, or you can say 1 divided by e to the 1/2, okay? Remember, negative exponent means that e to the 1/2, that is downstairs, is 1 over e to the 1/2. But what's e to the 1/2? 1/2 exponent is square root. Okay, so therefore, this original limit, the limit as x approaches 0, 1 plus x to the 1 over x all over e, and that whole thing is raised to 1 over sine of x, that limit is going to equal 1 divided by square root of e. So this is a very interesting question that requires you to use L'Hopital's rule twice.